In example 5, we're asked to find the general solution to the differential equation given on the right-hand side. The general solution to a differential equation is an equation that has a derivative of, in this case, cosine x e to the sine x over cosine y. The very first thing to do with these types of problems when finding a general solution is to separate your variables. So what we'll do here is we'll multiply by dx on each side to start this one off. And then we'll also multiply by the cosine of y on each side. You can do those in separate steps. If you do them in one step, here's what's going to happen. Dx cancels out on the left, cosine y cancels out on the right, and we wind up with the cosine of y dy is equal to cosine of x e to the sine x dx. We've now successfully separated all of our variables. I have an expression on the left, or a factor, cosine y in terms of y, and then everything on the right-hand side is in terms of x. My next step is to integrate each side. To integrate the left side, it's not that terrible. The antiderivative of the cosine is the sine. In other words, the sine has a derivative of the cosine. The right-hand side, it's a little bit trickier. If you do need to use a different method, you can use u substitution. So for this one, I can see that the sine of x right here is inside of the e to that power. So what I'm going to do is I'm going to let u equal the sine of x. If I find the derivative with respect to x of each side, I wind up with du dx being equal to the cosine of x. Multiplying by dx on each side, I have du is equal to cosine x dx. It's supposed to be a dx there. And there's your cosine of x. And then I can also divide by the cosine of x on each side, if that helps. So I find dx being equal to du over the cosine of x. When I rewrite this integral expression, then I'll have the cosine of x, and I'm just going to put that over 1 so that we can keep track of that. That's our first cosine. And then I've got e to the u power. Remember, u is equal to the sine of x. If you want to put that over 1, you can. And then dx over here on the right-hand side, this guy is equal to du over cosine x. So you can just replace that with du over cosine x. The cosine x's luckily cancel out, and then we can write that right-hand integral as just e to the u du. On the left-hand side, we still have the sine of y. We've already done the antiderivative there. As I continue to work with the right-hand side, I'll have the integral of e to the u du, and that's an easy one. That happens to be e to the u, and then plus c. To get back to something in terms of x on the right-hand side, what I need to do now is I need to replace that u with what u is equal to. And if we look up here, we're the ones that let u equal the sine of x. So we'll take that u out right up here, and we'll replace it with the sine of x. And we still have a plus c. The only thing left to do now is to solve for y. And notice we're trying to solve for an angle here. It's always the sine, cosine, or tangent of an angle. And so we can change this into an inverse. We know that y then will be equal to the inverse sine of whatever's on the right-hand side of the equal sign before, and that's e to the sine of x power plus c. Believe it or not, that is the general solution to this particular, for this differential equation.